Alright, now we should. Okay. Alright, so there are definitions that you guys will need to know. And let me make sure that we are aware. You can, obviously take your own notes here, but the most important thing is at the very, very end of this objective, because I tell you, hey, what do you need to do if you need to find this? What do you need to do if you need to find this? And it's step by step, based upon the vocabulary. So we're going to talk about critical points, we're going to talk about increasing and decreasing, we're going to talk about max and min, we're going to talk about absolute max and min, and for some reason concavity is not on here, but we will talk about concavity as well. But I just want you guys to be aware that at the end of this section has like a how-to. Okay. Alright, so go back to the first page. Okay, so I'm going to ask you to find a variety of things, and they're characteristics of a graph. Okay. Certain graphs have certain characteristics, and some of them don't have everything, they only have some. So, one of the first things I can ask you to do is find a critical number. The reason why there's a Google form associated with this section is because I can ask you guys multiple choice questions regarding all this stuff. So I can ask you to find a critical number, but to take a 28 question multiple choice test on increasing, decreasing, concavity, and all of this stuff is actually pretty overwhelming. So I'll give you guys the Google form practice. In the end, I'm meshing these Google forms with previous Google forms put together, helps you to study for the midterm that will be after this test. Okay. But I can ask you for a critical number. A critical number is when I take the derivative and I set it equal to 0, or where the derivative is undefined. So if I had a denominator of the derivative and I set that equal to 0 and I solved, that would also be a critical number. Increasing and decreasing. A function is increasing left to right if the tangent lines are positive, have positive slope. So that means that the derivative has to be bigger than 0. Likewise, if we're decreasing, slopes of the tangent lines would be negative. So that means that f prime of x would be less than 0. At a critical number is where I turn from increasing to decreasing, or decreasing to increasing. So at that critical number is where the derivative is equal to 0. It's not increasing nor is it decreasing. At that critical number is also where I can have possibly a minimum value or a maximum value, depending on what happens to the tangent line on each side. So there's a lot of testing that we're going to have to do. What does the derivative look like to the left of a critical point? What does it look like to the right of a critical point? And there's a lot of words here, but it'll make more sense when we actually do it. So if you look here at this picture, my f of x is increasing. Because the slopes of the tangent line are bigger than 0, so they're positive. It is also increasing on this side. Again, because f prime is bigger than 0. F prime is, slopes of my tangent lines are negative, so f prime is less than 0, so f is decreasing. And what you notice is that I have a hill where I go from increasing to decreasing. This is called a relative maximum. And f prime is equal to 0 at that point. When I go from decreasing to increasing, I have a valley, and that is a relative minimum because I go from decreasing to increasing. And again, f prime is equal to 0. F prime being equal to 0 means that both of these points, you have a horizontal tangent. So it's kind of sort of connecting things together. Okay. Now the question is how do we find all of this stuff? Which you're not going to like. Because you have a tendency of not liking when I tell you have to write things a certain way. Okay. We're going to skip to the actual example here. Okay. So, I want to figure out where f is increasing, decreasing, has a relative max, and a relative minimum. If I ask you for a relative max and a relative minimum, if I don't have one of them, I have to state that I don't have one of them and why. Okay, so if I specifically ask for both of them, don't just say, oh, here's my relative maximum, and when you don't have a relative minimum that you don't say anything. Okay, you have to state both, because you do get points for both, which all the BC people are going to find out today that their quiz scores are probably not going to be what they want. Yeah, I probably got to put up all the answers to their quiz all along with point values, because you guys get points for certain things. Because this is free response, you're going to be taking a first derivative and setting it equal to 0. You're going to be taking a second derivative and setting it equal to 0. Bless you. When in doubt, take the derivative and set it equal to 0 everywhere to try to get some points. But in the end, if you don't show me taking the derivative and setting it equal to 0, and that's part of giving you 1 point, you don't get the point even if you get the right answer. So you just have to know. It's a game. Like the free response is like a game. It's like how well, yeah, it's not the best game to play. But in the end, it's like playing. But in the end, sorry.
More Mario.
I know, more Mario. But in the end, you know, it is about like learning how the point values are assigned. Okay. Alright, so I'm going to take the derivative because I want to find critical numbers. So when I want to find critical numbers, my first thing, take the derivative, set it equal to 0, solve for x. So derivative of x cubed is 3x squared. Derivative of 3 halves x squared is minus 3x. So bring down the 2. See, I picked that for a reason. I'm going to set it equal to 0. And then I have a greatest common factor of 3x. And I'm left with x minus 1. So when I solve for x, I get x is equal to 0 and 1. And these are the critical numbers of f of x. If I had a denominator with my derivative and I was able to set that equal to 0 and solve, then I would also have critical numbers where the derivative does not exist. Okay. But in this case, it was just a line. Now, I have to find lots of things. We are going to do a chart. You're going to ask me if I have to draw the chart every single time. The answer is yes. Can you abbreviate the chart? The answer is no. Can I use a number line? The answer is no. So if you go and get tutoring somewhere else and they show you a number line, you're not allowed to use a number line on a free response test. I can care less what you do on a multiple choice, but on a free response, you have to show the chart or you don't get credit. Why? Because that's college work. That's the second thing. So, don't abbreviate test value as TD. That is not acceptable. You have to actually physically write all this stuff out. Okay. I know. Alright, so you don't have to draw the squiggle lines. I just can't draw straight lines. And so I don't even try. Okay. There is no interval that's given. So I was not given a closed interval. This was so basically I can go from negative infinity all the way to positive infinity. So my interval is going to go from negative infinity to my first critical number, which is 0. Then I'm going to go 0 to my next critical number of 1. Then I'm going to go from 1, which is my critical number, to infinity. And my terms by 2. We did a chart similar to this in advanced math that nobody liked.
I mean, that is.
It's just tedious, and it's annoying. Okay, pick a number smaller than 0. Negative 1. Pick a number between 0 and 1. 1/2. Pick a number bigger than 1. 2. Now, it's the sign of f prime of x. What I want to do is I want to take negative 1 and I want to plug it into my derivative. I don't care what the actual number is. All I care about is it bigger than 0 or less than 0. So I would probably look at my factored form. When I plug in a negative into my x, I get a negative 3x, or sorry, negative 3. And then I plug it in negative 1 into x minus 1, I also get a negative value. Two negatives multiplied together gives me a positive. So this is greater than 0. When I plug in a half, I get a positive times a negative. So I get less than 0, and then when I do 2, both of them are positive. They do not always alternate. You'll find a pattern as far as when they alternate and when they don't. Anytime your derivative has a quantity squared or to the 4th power, or some sort of even power around that critical number, you won't change direction. Because technically it bounces, the graph bounces, it doesn't actually cross through the axis. So, because my derivative is bigger than 0, remember up here, way back in here, f prime being bigger than 0 means that the function is increasing. F prime being less than 0 means that the function is decreasing. So, when I go back here, f prime being bigger than 0 is where f of x is increasing. And where it's less than 0 is where f is decreasing. So I found critical numbers. My first thing was to identify an increasing and decreasing. So f is increasing on the interval from negative infinity to 0, union 1 to infinity. Because f prime is bigger than 0. F is decreasing on the interval from 0 to 1 because f prime is less than. Now, because I did not ask you to justify your answer, what I've highlighted in green would be permissible. It would be acceptable because I didn't ask you to justify your answer. Anytime I ask you to justify your answer, you have to write because of whatever. Don't use don't use general terms, so don't use because the graph. Okay, you have to actually use like f prime, f double prime, f of x, use the actual function. Questions so far? Yes, fine. Derivative. Correct, and not setting it equal to 0. Other questions that you guys have? We're not done yet. Where the function goes from increasing to decreasing, you have a relative maximum. Where the function goes from decreasing to increasing, you have a relative minimum. These are coordinate points, so you must find the corresponding value of y. Now let me be clear, the value of y, not y prime, not y double prime, the value of y. If I'm asking for the value of y, it has to go into the original equation, not the derivative. Yes, Tim?
Like, not to be confusing, but like, if you're having this for physics purposes, this is finding acceleration, not different. Like, something's accelerating or decelerating because you're finding.
Where the particles moving to the right is the left.
Yeah. Okay.
So increasing and decreasing. So when the function is increasing is when the particle will be moved to the right. When the particle is
So you're finding negative, positive acceleration.
velocity.
Is it going left or right?
Velocity.
Velocity. Slope is velocity? Or slope is acceleration?
Double derivative is acceleration.
Okay.
So when you look at concavity of the function, we're looking at what the acceleration is.
Okay.
Other questions that you guys have? So we plug this back into the original equation. So I want f of 0, which is 0 cubed minus 3 halves times 0 squared, which is sides, which is 0. And then f of 1, which is 1 cubed minus 3 halves times 1 squared, which is negative 1 half. So that means that f has a relative. You can abbreviate max and min, but that is the only thing you can abbreviate. Relative max at 0, 0. And f has a relative minimum at 1 comma negative 1 half. Good question. So if I have to justify my answer for the relative max, it would be because f changes from increasing to decreasing. And you can do it a variety of ways. You could have said because f prime goes from bigger than 0 to less than 0. But because what I'm going to try to do is be a little lazy with my justification. I'm going to restate what's already in my chart. And because I use f as increasing and f as decreasing, that's the reason why I would do that. You can do other ways, but it can get a little tricky, especially if you say, like, use general terms. I always try to use my justification for what I already wrote in the chart. That's a good question about justification. Other questions that you guys have? Before we talk about absolute maximum.
Absolutely.
Yes, that. Okay, other questions that you guys have? not because I don't want to do trig. The only difference with the trig is that when you take the derivative and set it equal to 0, you have to remember that you always have two values typically for sine and cosine. That's the only reason why I actually put the trig one in there is mainly for you guys to remember to solve it correctly. So let's be clear about extrema, this word extrema. Extrema means relative max and relative minimum. And it also means absolute. Also, because College Word loves to change words on you, the word relative can be interchanged with the word local. So the directions that they ask you for a local max or min, that's what they're asking for. Or absolute can be interchanged with the word global. They change words based upon how old they are.
Is that a real world example?
So, depending on the year of the test that they pull from, and they modify, will determine whether or not it's local or global versus absolute. But they all mean the same thing. Now, when I ask you to find extrema, I'm asking you to find everybody. So relative min, relative max, absolute min, absolute max. Now, an absolute min and an absolute max are the absolute highest y value you will have and the absolute lowest y value you will have. So the absolute maximum is the largest y value, the most positive y value you get, and your absolute minimum is the most negative y value you get. Okay? Now your absolute mins and absolute maxes, you can only find them if two cases. One, you have a closed interval that's given. Or two, it's a quadratic. Because at a quadratic, your vertex will either be an absolute minimum or an absolute maximum. But you'll never have a relative with a quadratic. Okay. Unless we're rounded. But rarely we don't. Okay, so when I look at this, I have to find everything. So I have to, because I'm looking for the largest y value I can possibly have and the smallest y value I can possibly have, it doesn't necessarily occur at the endpoints. So the endpoints can be like this, and somewhere my critical numbers can be really, really high or really, really low. And so my absolute can occur at a critical number. I will say this too. Your relative min and relative max is defined as the function changing from increasing to decreasing or decreasing to increasing. So I cannot have a relative min or relative max at an endpoint. You can only have a relative min or relative max at a critical number. Okay, so it doesn't go both ways. Okay, so let's find a derivative. Yay! We'll do second derivative with 3-5. So f prime of x is equal to x cubed minus 12x squared. When we get to 3-5, I'm going to try to remember, but if somebody can remind me, your 3-5 and your review are the exact same thing. I need to hand to a new 3-5.
Well done there, Mike.
Well, you'll remind me when you're like, what's wrong with the review? That's when it'll happen. Okay, so I'm going to set this equal to 0 and I'm going to factor. So I get 0 and 1. I love 0 and 1. I'm going to use 0 and 1 as many times as possible. Now don't get excited. I gave you a closed interval, so you can't go to negative infinity. go from negative 1 to 0, 0 to 1, and then 1 to 2. The question is going to come up, why am I doing this when I'm finding extrema? I have to first figure out my possible candidates for relative mins and relative maxes. I have to first find critical numbers before I can go through and find the largest and smallest y values. What you'll notice is that I'm going to pick my test values, so negative 1/2, 1/2, and 3/2. Lots of halves. When I do my derivative, f prime of negative 1/2 is going to be, less than 0. F prime of positive 1/2 is also going to be less than 0. So I don't change direction. And then f prime of 3/2 will be bigger than 0. But now my only candidate for a possible relative or absolute maximum is not at 0. I started the wrong one. Is at 1. Because that's the only one that changes direction. So f is decreasing. F is decreasing. And f is increasing. And I know I don't ask for this, but if I were to write f is decreasing on the interval, it has to be on the interval from negative 1 to 0, union 0 to 1. Do not go all the way to 1 without breaking it up, because at x equals 0, the derivative is equal to 0, so it's not increasing or is it decreasing at that point. Okay? Yes, kids.
But when it equals 0, isn't that like a relative maximum or a relative minimum?
Only if it changes direction.
Okay, if it equals 0 and it doesn't change direction, is that an expression or no?
No. It's just where you have horizontal tangent. That's all.
Okay.
Because I can have this situation here where I have a horizontal tangent line, but my thing doesn't change direction. Okay, and then just to finish it, so it's nice. F is increasing from 1 to 2. Now, somebody asked in BC, so I just wanted to make sure that you guys were aware too. At negative 1, because I am in closed bracket, you could have used negative 1 as a test line. So you can use, because it's an equal to, you can use your bracketed values. You just can't use your parentheses values.
So we can't go outside, our test values can't get outside of that.
Correct, but I could have used negative 1 if I wanted to, and I could have used 2.
Oh, and we can't go outside of it because it's the parentheses.
Well, parentheses, I mean, you can get as close to that value as you want, but you can't use that value in parentheses if you go all the way to that.
Yeah.
So it has to be between negative 1. It can be negative 1 all the way up to 0, but not all the way to 0.
So it's stay inside.
Is say, yeah, you have to stay on the left side.
So they can open that.
So let's find some values. Now I cannot do 0. So I need to find f of the end point, which is negative 1. I need to find f of 1. And I also need to find f of 2. Again, you could have done this with synthetic division, or you could just plug it in. So I get 3 plus 4, which is 7. 3 times 1 to the 4 minus 4 times 1 cubed is 3 minus 4, which is negative 1. And then 3 times 2 to the 4th absolute minimum at 1 comma negative 1, and n has an absolute maximum at 2 comma 16, and there is no relative max or min. And the reason why is because you can't have a relative min or relative max at an endpoint. You can't.
How do you choose those points that you're plugging in to find the y value?
One of them is the critical number,
Okay, so one's good.
and I did not do 0 because it didn't change direction. And then the other one are my 2 endpoints.
Okay. And then, how do you know, like,
Which one is which?
Yeah, they go through the points.
Smallest y value, largest y value. This was an endpoint, so I can't have a relative and a relative maximum. Question?
I was gonna ask that also, how do you know that 7 is an endpoint?
The what?
That 7 is an endpoint?
Oh, because -1. -1 was the x value that you
Oh.
put. Yeah. Yeah, so whatever corresponding y value is with that particular endpoint that you plugged in for x.
And then the one that you plugged in is from the interval 0, comma 1. And where did you get y? Where did you plug in y from?
One is from, it's from this chart. Because I changed from decreasing to increasing that value.
And then, since that's where it changes, that's where you plug it in.
Yes.
It changes the one, okay, and then,
And if it would have changed in 0, I would have done 0 also, but it doesn't change direction.
so you plug in for the endpoint and where it changes.
And if it had changed there, would there be a relative maximum?
There could have been a relative maximum.
So if we have one change,
No, none of those are. Because my absolutes can occur at endpoints or they can occur at. I know. That's why we have 2 days off. Yes,
And then the reason why 1 is not a relative is because it's the absolute.
correct. Yep. Other questions that you raised? We have 10 minutes to start. I would start with the grade scale. Because the grade scale is going to require the chart and everything to start with the grade scale.
Is this Hayden?
Yes.